Let us look at the number system that Euclid explores in his book 10 of Elements. I'm going to cover a brief snapshot of book 10. He starts off by talking of commensurable numbers. So here NM, where NM are both numbers having a common measure. That means both these numbers can be measured by another number. Whole numbers are commensurable with each other. Say for example, 2 and 3, they are commensurable because they both can be measured by 1. Now when we talk of commensurability, it can be commensurable in length or in square or both or only in square. Then it talks of incommensurable numbers, numbers not having a common measure. For example, n and root m. Now here n is a whole number and m is not a perfect square. Because if it is a perfect square, the root will disappear. Then they will become commensurable. So that's why this condition is there, that m is not a perfect square. Now incommensurable in length, but these magnitudes may be commensurable in square. Magnitudes may be incommensurable in length and incommensurable in square as well. We will look at all these as we go along. So let's look at rational number. He says a rational number can be written in as a ratio of number is to number. So n is to m. So n, m are whole numbers and are commensurable with each other. Then we have medial numbers. A ratio which is not equal to a number is to number and also not equal to a number square is to number square. So something like this, n is to square root of m. So square root of m is irrational. So n is to square root m cannot be written as a ratio of number to number. Similarly, even if we square them so that it becomes n square is to root m, even then they are not commensurable. So here n and root m are incommensurable in length and in square also. Then we come to binomial number. Sum of two numbers commensurable in square only. So here we have two numbers, n and root m. So n and m are rational and commensurable in square only. So commensurable in square only means what? N square is commensurable with square root of m square, which becomes m. So n square is commensurable with m. Then we have first bimedial straight line. So sum of two medial lines commensurable in square only. Here we have n times square root of m plus n times square root of m cube. And another condition that is attached to this first bimedial straight lines is that the rectangle contained by them is rational. That means if you multiply these two, you will end up with a rational number. So here we have n times square root of m times n times square root of m cube. So here you can think of this as m to the power of 1 by 4. And this will be m to the power of 3 by 4. Since it is being multiplied, that means the exponents will get added up. So we end up with n square times m to the power of 1 by 4 plus 3 by 4. So 1 by 4 plus 3 by 4 is 1. So we have n square times m, which is rational. Then we have second bimedial straight line. So sum of two medial lines commensurable in square only. So this is an example of that, or this is the formula for that. So n times square root of m plus n times square root of p by square root of m. And the rectangle contained by them is medial. So these two are medial lines. And if we take the product of these two, which is what a rectangle area is, then we have n times square root of m times n times square root of p by square root of m. So square root of m will get cancelled out. We are left with n square times square root of p. So again, if you notice, n square and root p are commensurable in square only. So that means the rectangle is medial. So just to give you a little bit more insight about medial rectangle, let's look at the next medial rectangle itself. It is a rectangle contained by two magnitudes commensurable in square only. Another way of looking at it is the side of a square equal to the rectangle. So here when we say square equal to the rectangle, we are talking in terms of areas. So side of a square equal to the area of the rectangle. So here we had n square times root p. So let's say r square is equal to n square times root p. So r will become square root of n square times root p, which means r will be equal to n times root p, which is what a medial is. So that is what a medial rectangle is. Then we have the other number, that is major. So sum of two lines incommensurable in square such that sum of the squares on them is rational and rectangle contained by them is medial. These are the two straight lines incommensurable in square. So take the square of these two, we end up with n square by 2, n square by 2. So they are commensurable. But what about these two? If we take the square on this root will disappear, this root will disappear. We have 1 plus m by square root of 1 plus m square. And we have 1 minus m by square root of 1 plus m square. And they are incommensurable because of the square root in the denominator. Again, you can try out. Take the square of this, take the square of this, add them up. When you add them up, you should get a rational number. That means all the square root should disappear. Similarly, if you multiply these two, you should end up with a medial. I have shown for 2, rest I will not be showing. You can try it out. Now, side of a rational plus a medial area. So, sum of two straight lines incommensurable in square such that sum of the square on them is medial and rectangle contained by them is rational. So, here we have one straight line, another straight line, or we can say one magnitude, another magnitude. They are incommensurable in square. So take the square, we end up with n square and n square. Root 2, if we separate it out, we end up with 2 when we square 2. So n by 2, n by 2. That's okay. Now let's look at this. When we square them, what happens? Only the top square root disappears. This square root disappears. This top square root disappears. This square root disappears. So we still are left with s square root 1 plus m square plus m. And here we have 1 plus m square minus m. So try it out. Take the squares, add them up, and you will realize that it is a medial. Similarly, multiply these two. When you multiply these two, you will end up with a rational rectangle. So basically what Euclid does is, whenever he talks of multiplication, he doesn't say multiply. He says the rectangle contained by those two magnitudes. So basically rectangle means the area of the rectangle, which is nothing but length into breadth. So which is what these two represents in a rectangle. So that is why he says rectangle contained by them is rational. Side of the sum of two medial areas. So sum of two straight lines incommensurable in square such that sum of the squares on them is medial, rectangle contained by them is medial, rectangle contained by them is incommensurable with the sum of the squares in them. So he arrives at this. Remember, he doesn't arrive at this formula itself. Geometrically, he arrives at this conclusion. So n times square root of p by square root of 2 times square root of 1 plus m divided by square root of 1 plus m square is one number. Another number is n times square root of p by square root of 2 times square root of 1 minus m by square root of 1 plus m square. Now take the square of each, add them up. You will end up with a medial. Multiply these two. Again, you will end up with a medial. And the sum of the squares and the rectangle contained by them would be incommensurable. So here, if you notice, we were talking of addition. All these were additions, adding two numbers. Now he starts off with subtraction. So difference of two rational straight lines commensurable in square only is called an epitome. N minus n times square root of m. Now these two are commensurable in square only because they are not commensurable because of this square root. But when we square them, what happens? N square, and here we have n square times m. So they are commensurable. N and m are rational. Then we have first epitome of a medial line. If a medial straight line is subtracted from a medial straight line such that subtrahend is commensurable with the minuend in square only, and the rectangle contained by the minuend and the subtrahend is rational, then it is called a first epitome of a medial line. And this is the conclusion of that proposition of S. N times square root of m, which is a medial, n times square root of m cube is a medial. Subtracting it, we end up with they both being commensurable in square only. And if we multiply these two, we get a rational. N times n, n square, square root of m, that is m to the power of 1 by 4, m to the power of 3 by 4. So if you multiply these two, 1 by 4 plus 3 by 4 becomes 1. So you end up with n square times m. He talks of second epitome of a medial line. If a medial straight line is subtracted from a medial straight line such that subtrahend is commensurable with the minuend in square only, and the rectangle contained by the minuend and the subtrahend is medial, then it is called a second epitome of a medial line. So look at the difference between these two. They are commensurable in square only because of the root p. But if we multiply these two, what happens? N square, square root of m get cancelled out. N times n is n square times root p, which means it is medial. So then we have minor. If a medial straight line is subtracted from a straight line such that subtrahend is incommensurable with the minuend in square, sum of the squares on them is rational, and the rectangle contained by the minuend and the subtrahend is medial. So again, this is the modern way of putting it. So here, this and this are incommensurable in square because of this square root of 1 plus m square in the denominator. Now, sum of the squares on them is rational. So n by root 2 square will be n square by 2. Here also n square by 2. This square root will disappear. So we are left with 1 plus m by square root of 1 plus m square. And here we are left with 1 minus m by square root of 1 plus m square. And here what we will end up with is that m by square root of 1 plus m square minus m by square root of 1 plus square root of 1 plus m square, they will get cancelled out. So we will have n square by 2 times 2, 1 plus 1. Remember, don't ignore this subtraction because here we are talking about sum of the squares on them rational. So we will end up with a rational sum of the squares. Now, if we multiply these two, we will end up with a median. Now, let's look at the next number. That which produces with a rational area a medial whole. So here, if a medial straight line is subtracted from a straight line such that subtrahend is incommensurable with the minuend in square, sum of the squares on them is medial, the rectangle contained by them is rational, then it is called that which produces with a rational area a medial whole. I will let you do the squaring and adding them up and see whether it is medial or not. Similarly, multiply these two. Then you should end up with a rational. And finally, we have that which produces with a medial area a medial whole. So if a medial straight line is subtracted from a straight line such that subtrahend is incommensurable with the minuend in square, sum of the squares from them is medial, the rectangle contained by them is medial, the sum of the squares from them is incommensurable with the rectangle contained by them, then it is called that which produces with a medial area a medial. So this is what we arrive at. So these two are incommensurable in square. The sum of the squares, square of this plus square of this is medial. This times this is medial, and the sum of the squares and the product of these two are incommensurable with each other. So that is the number system that Euclid explores in his book Elements, specifically in book 10. So that's it for now.